Uh, Today we would be talking about a project where our main goal was to identify handwritten digits which the users would be submitting via a scanner or maybe any portable device. So our motto was to develop such a model using support vector machine which would be able to identify the particular digit based on the pixel values provided as features in our dataset. So for this purpose, we used the MNIST data set, which is a large database of handwritten digits where we have the pixel values of each digit along with its label. This would be used as our training data set to build our model. Now we would be using the basic CRISP DM methodology, so the business understanding is always anyways clear to us. Now we would move into the data understanding and data sourcing and data preparation phase. Now the data set that we had where the train data set and the test data set were two different files. So before performing any kind of data preparation, we first need to combine them to a single file so that all the manipulations that we do on the data are uniform across the train and the test data set. So firstly we merge them, and then we found the categorical variable, that is the first column, which contains the digits like 1 0 to 9, whose attributes in pixel values are displayed in the next of the attributes. In the data preparation phase, it was followed by the next step, that is the scaling or normalizing of the continuous variables that were to be done. Now, after this brief stage of data preparation, we come on to the model building phase, and for that we would take only 10% of the data because the data set is very huge and SVM is in any ways computationally exhaustive. So we won't be taking the entire data set. Instead, we would be working on 10% of the data set to create our model. Now the basic approach that we took in this model building phase was to first build the model using a vanilla.kernel and also use the RBF kernel to build the model, and then check what is the accuracy in each of the cases. If we get a very good accuracy in the vanilla.model, that would show that we need not go for a very complex hyperplane, and the sigma value could be low. That would work for us. Accordingly, we found out that we got pretty much like 91% accuracy with a vanilla dot model, which showed us that maybe we would require lower values of sigma, that is lower complex and so the discriminator should be kind of linear, and that would give us pretty accurate values. So we tried that out with various lower values of sigma, and also we chose accordingly values of c, and after many trials and errors we found that the sigma value of 0.001 along with a value of c as 3 would give us a pretty accurate model with 93% accuracy. Now once the model building was complete, we used it on the validation set of data which we kept aside, and that also gave us a pretty good accuracy above 90%, and same was the case for the test data. It also gave us a pretty accurate result above 90%. So we understood that for digit recognition we need not use a very complex kernel like RBF. A simple linear kernel would work for us and give us pretty accurate results.